Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is part 2 of chapter 17, Reflection and Refraction in Physics. And here you can see how it's lighter under the rainbow, and that the double rainbow is in opposite order. So that's interesting, isn't it? Okay, so remember, reflection is back, bounce back, refraction is bent. And we're going to look at the math now. Here's Snell's law. You just divide the sign of incidence over the sign of refraction. Okay, there's our lab we're going to do, and here's our first problem. All right, it says, a ray of light traveling through the air is incident upon a sheet of crown glass at an angle of 30 degrees. What is the angle of refraction? Okay, so how you know this is you have to look at this chart. You have to look up N on the chart. And the N in air is about 1, and the N for ground glass is 1.52. The angle is 30 degrees for the angle of incidence, and we want theta sub r. And here's our formula, and it's the N times the sine of theta, N times the sine of theta. So that's how I set it up. I like to do it like that. I substitute everything I know, and one thing will be left off, and then I start solving it. So y is theta not alone? Well, it's being multiplied by 1.52, so I divide both sides by 1.52. Then I get the sine is this, so I do the inverse sine, which is the button on your calculator, which is the second of sine. See it right there? Sine -1, and you get that it's 19.2 degrees. Ta-da, 19.2 degrees. So you see, I set it up a little different than they do. They rearrange their equation for what they're solving for. I never do that because it helps me memorize my equations. Okay, here's problem number 2. The incident of refraction of water is 1.33. Calculate the speed of light in water. Remember, speed of light is speed of light in a vacuum, so this is speed of light in water. So the N for water is 1.33. The speed of light in a vacuum, C, is 3 times 10 to the 8 meters per second. The V sub W would be speed of light in water, so that's what we're looking for. And our formula is right here. N equals C over V, speed of light over velocity. And we substitute in what we know. We know 133 for N, and we know C. And C, once again, I don't rearrange. I keep it like it is, and it might take an extra step, but I end up memorizing my formula. It's very handy. So I'll multiply both sides by V of W to get out of the denominator. Remember, the first, how you solve a problem is by doing the opposite of why it's not alone, unless it's ugly. And if it's ugly, you de-uglyify it first. And what is ugly is our unknown is in the denominator. So we're going to get rid of that first. We're going to multiply both sides by V sub W. Those cancel out. And then we're going to divide both sides by 1.33. And then we put it in our calculator, and that's the answer we get. But then we put it in scientific notation because they did, and we want to make sure we did it right. And dun-dun-dun, we did. Yay, go us. Okay, let's see if there's any more. I think that's a weird looking picture. It's Barbie reflected, so those are her legs, and those are her legs, but those are her arms. It makes her look very weird. All right, there's our fiber optics. Oh, mirages, read this in the book, and there's also more videos you can watch about mirages. I sort of skipped that. It's interesting. There's the light in the rainbow being done. All right, and that's chapter 17. It's a pretty easy chapter. Have fun doing it, and come back for chapter 18. Like, share, subscribe. Science is great.